All right, so now we're going to be learning about two more rules, the product rule and the quotient rule. Okay, the product rule we're going to use when we have a function that is the product of two other functions. So the way the product rule works is this. If I want to take the derivative of something that is the product of two functions, and you're going to hear me refer to it this way. I'm going to call this one the first and this one the second. So it works like this. I'm going to write down the first, leave it alone, write it exactly as it appears, times the derivative of the second. We can also call that g prime x if you prefer. Okay, plus the second, leave it alone, don't do anything to it, times the derivative of the first, otherwise known as f prime. Okay, and some people like to organize their parts this way. Go ahead before you start and write down what f of x is, write down what f prime is, write down what g of x is, and write down what g prime is, because then you have all the four parts listed out for you. So let's see how this works. Here's our first example, and I'm going to go ahead, I'm going to write out the four parts so that we can see that way. I don't usually do that, but we will this time. So f of x is x to the fourth minus 2x cubed minus 7, which means f prime is going to be 4x cubed minus 6x squared. G of x is 3x squared minus 5x, which means g prime of x equals 6x minus 5. Okay, so we have the four parts. All right, so let's go ahead. Oops, I want to show that all on the screen. All right, so let's go ahead. The first, leave it alone. So I wrote f of x down exactly as it appears, times the derivative of the second. So that's my g prime. So that's 6x minus 5, plus the second. Well, here's your second. So 3x squared, exactly as it started out, times the derivative of the first. And here's your derivative of the first, which is 4x cubed minus 6x squared. We can label these this way. This was f of x, g prime of x, g of x, and f prime of x. Okay? All right. That only gets you half credit, though. Now we have a lot of multiplication to do. So let's go ahead and multiply these things out. So I have 6x to the fifth minus 5x to the fourth. I'm taking this x to the fourth and multiplying by each of the things over here, and then I'm going to move on to the negative 2x cubed. So I have negative 2x cubed times 6x, so negative 12x to the fourth, plus 10x cubed, and then the negative 7, so negative 42x plus 35, plus, now I've got to go to the other side. So now I have 3x squared plus 4x cubed, so that's going to be 12x to the fifth minus 18x to the fourth minus 20x to the fourth plus 30x cubed. Okay, now at this point we have to combine like terms. So I suggest that you get some kind of colored pens or write shapes or something. So I'm going to go ahead and underline things in different colors, the things that match. So we have 6x to the fifth and 12x to the fifth. So that will be 18x to the fifth. See what I'm have here? Red, we'll do 4, 4, 4, and 4. So we have negative 30, looks like minus 1 second. 55 x to the 4th cubes. I have 1 here and 1 here, so it looks like plus 40x cubed. And then I have minus 42x. And then this 35 is just hanging out by itself, plus 35. So that should be our final answer. Okay, it is a long process, but that's how you're going to get the derivative. All right, let's go ahead and look at another example. Okay, I want you to try to do this on your own, so please go ahead and cross that out. Please go ahead and give this a try, pause the video and come back. I'm going to go ahead and write x equals 2x to the 5th plus x minus 1, f prime 10x to the 4th plus 1, g of x 3x minus 2, and g prime of x equals 3. All right, so y prime equals 2x to the 5th plus x minus 1 times 3 plus 3x minus 2 times 10x to the 4th plus 1. So I have the first times the derivative of the second, so f of x times g prime plus g of x times f prime. And let's multiply this out. So we're going to have 6x to the 5th plus 3x minus 3 plus 30x to the 5th plus 3x minus 20x to the 4th minus 2. Okay, I think I got them all there. Let's get some colors. Start with a yellow. So I have a 6x to the 5th and a 30x to the 5th. So that's 36x to the 5th. And we have minus 20x to the 4th. Plus 3x and plus 3x. So that's going to be plus 6x. And negative 3 and negative 2, which will be minus 5. So that should be your y prime. 36x to the 5th minus 20x to the 4th plus 6x minus 5. All right. We already did that problem. This was the solution page. Okay. So the next one is called the quotient rule. Okay, so you have a fraction this time. So you've got a numerator to your fraction, numerator, otherwise known as top, and a denominator, otherwise known as bottom. Okay, now it's very, very important that you do this in the proper order. Okay, so this is, and I'm going to use the words bottom and top. Bottom, leave it alone. Write the bottom exactly as it appears, times the derivative of the top minus top, leave it alone, times the derivative of the bottom, and all of that is over bottom squared. Okay, so some of you might like to write out derivative, derivative prime, I'm sorry, denominator, denominator prime, numerator, numerator prime, and write that out so that you have the pieces ahead of time. All right, so here's our first example. So we have the bottom, leave it alone. If I want f prime of x, it's going to be the bottom, leave it alone, times the derivative of the top. The derivative of the top is going to be 2x minus 3 minus, remember this sign is different from the product rule, the top, x squared minus 3x times the derivative of the bottom, which is 1, and all of that is over bottom squared. Okay, one thing, we're not going to do anything with the bottom. We're not going to square that out. We're going to leave it like it is. So what happens is that a lot of you are going to forget to drag that along because there's no work to be done there. We get a little lazy. I do it too. And we just do the work in the bottom. But we forget when we get our final answer, it has to have this piece in it. If you were one of those people, I suggest making an answer space over here. Go ahead and put the bottom in it because you know it's going to be there. And then we'll work in our workspace with just working with the numerator. So we have x times 2x, which is going to be 2x squared. X times negative 3, so negative 3x, negative 2x plus 3 minus. And here the 1 isn't going to change anything. Now, again, I put that second part in parentheses because, again, this is like having a negative 1 here, so it's going to change both of those signs. So I have 2x squared minus 3x minus 2x plus 3 minus x squared plus 3x. And let's combine our like terms. So I have 2x squared and a minus x squared. So that's just going to be x squared. I have negative 3x, negative 2x, and a positive 3x. And finally, I have plus 3. So that is your final answer. I think I got everything in there. All right, let's look at another example. Okay, here's another example. Go ahead and pause the video to try this one. All right, hopefully you had a chance to try it. And let's go ahead. Bottom, leave it alone, times the derivative of the top, which is negative 3, minus the top, leave it alone, times the derivative of the bottom, which is 2x. And all of that is over bottom squared. Okay, so I'm going to go ahead and make an answer space over here, x squared plus 2 squared. And let's do the work. So I'm going to have negative 3x squared minus 6 minus, and that's going to be 2x minus 6x squared. Distribute that negative. Okay, so we have negative 3x squared, positive 6x squared. So that is a positive 3x squared. We have a negative 2x. We have negative 6. Okay, so that should be your final answer. I want to try one more of these to give you practice. Now remember, there's more in your homework, so you can practice them there. The answers, I believe, to the odds should be in the back of the book, so try those. Here's our next one. This one's a little more complicated. So the bottom, leave it alone, times the derivative of the top. So that's going to be 28x cubed minus 9x squared plus 2 minus, I'm writing it down here because I ran out of room, the top, 7x to the fourth minus 3x cubed plus 2x minus 4 times the derivative of the bottom, which is 2x plus 2. Okay, now, I'm going to go ahead and put the bottom squared over here right now, 2x minus 3 squared, because I need all the workspace I can get up here. All right, multiply. Remember, multiply each term by all the terms in the next one. So my x squared, multiplied by each of those in the second one are 28x to the fifth minus 9x to the fourth plus 2x squared. And then I have plus 56x to the fourth minus 18x cubed. My 18x cubed plus 4x plus, let's start with the 3. And I have 3, 28. So I have, oops, that should not be a plus, that should be minus 84x cubed. Go into the next line, plus 27x squared minus 6. All right, all of that was just those two. Now we got to do the next part. Going to put it all in parentheses. So I have 7, remember all of those times all of those. So I have 14x to the fifth plus 14x to the fourth minus 6x to the fourth minus 6x cubed plus 4x squared plus 4x minus 8x minus 8. All right, all of that part was in parentheses. Okay, now we need to change all those signs and combine our like terms. I'm going to go through, because I don't want to have to rewrite all that, so let's change color and we'll change those signs. So this becomes a negative 14 x to the fifth. This is negative 14. That's plus, plus. That one will be a negative. That one will be a negative. That's plus, that's plus. Remember, this negative here changes all the signs inside the parentheses because we're subtracting that whole function. All right, now let's try to match up our terms. Start with purple. Okay, we have an x to the fifth and x to the fifth. I think that's all of them. So we have 14x to the fifth. Okay, our fourths. Okay, we have 4, we have 4, we have 4, we have 4. Okay, so 20 minus 9, that'd be 11. So it looks like, okay, that's minus 14 plus 6. So minus 14, so that's minus 8, minus 17. You know what? Just going to do this in the calculator so I don't mess it up. Minus 9 plus 56 minus 14 plus 6. So we have 39x to the fourth. All right, and we have cubes. There's a cube, there's a cube, there's a cube. I think that's all of them. I have 8. Okay, so negative 18 minus 84 and plus. So we have minus 96x cubed. Okay, so let's try our squares. I'm going to circle them to make them easier to see. There's a squared. There's a squared. That, remember, that one's going to be a negative. There's a squared. All right, so I have 27, 29 minus 4, so it looks like plus 25x squared. All right, let's see what's next. We need our x's. So x's, let's see, we'll do boxes. Okay, x and x, it looks like only 12x. Okay, and then the last ones are this and this, so we have plus 2. Now remember, all of that is going to go over x squared plus 2x minus 3 squared. Right, that was a more challenging one, but we did finally get to our final answer. This is a lot easier if you have colored pens, if you draw shapes around them, if you have colored highlighters, something so that you can highlight the ones that you've used so you know that you have used them. Oh, and it looks like I forgot one. I have a minus 4x there. So it looks like this is, let's see, a negative 4. Negative 4 is negative 8 plus 8. So that would be 0. So this should just be positive 4, 8, it's 12 minus 4. So this should be plus 8x because I missed one. Okay. But that lets you go back and see at the end if you have any that don't have the colors or the circles or whatever on them. All right. And the last part, we are in a business calculus class. So we want to talk about average cost, average revenue, and average profit. Okay, so average cost would be taking the cost function and dividing by the number of items made. That will give you average cost. The average revenue is the revenue divided by the number of items sold. And the average profit is the profit function divided by the number of items sold. Okay, so that's just a reminder. On the next page, we have a function here. Okay, so the cost of growing geraniums is here, and the revenue is here. Okay, so average cost. And we'll just do one of them. Okay, in fact, let's do profit because that would be the most difficult. Yeah, you know what? Let's not. Let's do just the revenue. Okay, so average revenue is going to be 120 plus 90, and I'm going to rewrite that as x to the 1/2 over x. That is our average revenue function. Okay, so there's your average revenue function. They don't tell us how many to put in, so they just want this function. But what they do want to know is the rate at which average profit, we're going to do average revenue, mostly because I don't want you to have to deal with that and that in the same problem. So that's why I decided not to do the profit function. I would not give you one quite that convoluted. Okay, so in order to find the rate at which average profit is changing, that is going to be a derivative. When you see rate, we should be thinking slope, we should be thinking derivative. The rate at which something changes is our derivative. So we want this average revenue, we want the derivative of that. Okay, so dy dx of 120 plus 90 x to the 1/2 divided by x. All right, so remember, the quotient rule says the bottom goes first, leave it alone, times the derivative of the top. Well, the derivative of the top is going to be 1/2 times 90. Well, that's 45 x to the negative 1/2 minus the top, leave it alone, times the derivative of the bottom, which is 1. Okay, and all of that goes over bottom squared. Okay, so we have 45x times x to the 1/2. Remember, when you're doing this, you need to add your exponents. So I need to add 1 and 1/2. So that's going to be x to the 1/2 minus. Now, the 1's not going to change anything, so I'm going to go ahead and change my signs. 120 minus 90x to the 1/2. All of that is over x squared. And let's simplify that. So I have 45 x to the 1/2 minus 90 of those same things. So that's negative 45 x to the 1/2 minus 120 over x squared. Okay, and to make it a little easier to evaluate, it makes more sense to us if we go ahead and convert that x to the 1/2 back to square root of x minus 120 over x squared. Okay, go ahead and throw that in your calculator. Let's see what that is. I'm going to put that in my y equals. Okay, so if I've done my math correctly, when I plugged 300 in, I got negative 0.010. So that means it is decreasing at a rate of negative 0.01. So small decrease when 300 geraniums are grown. Okay, that will change depending on the number of geraniums grown. So this is how you would use the quotient rule with your average cost, average profit, and average revenue functions. All right, that is all for tonight.